In this exercise, we're going to use a supervised machine learning to predict a continuous outcome variable. In other words, we have a regression task. We're going to work on the Toyota Corolla dataset. This dataset has the price of used Toyota Corolla cars, and there are many variables here. We're going to look at two variables, the price of the car as an outcome variable, and the KM, which is the accumulated kilometers on the odometer, as a main predictor, as a main feature to explain the outcome variable. In the next exercise, we're going to incorporate all of these variables. For this one, we're going to stick with just predicting price using KM. So first, we're going to read the data, and then the question is asking us to create a linear regression model and then interpret the model and evaluate its accuracy. So the steps are the following. First, we're going to pull our X and Y from the data. So the X will be the kilometers, and it has to be double brackets because in general there may be more features in my X, and the Y is going to be the price, simply speaking. The next step is to create a linear model, a linear regression model, or the machine learning model of choice. We're going to call it car linear model. For car linear regression, I'm going to create a linear regression model. The third step is to fit the model to the data, so I'm going to call the function fit X and Y. Now that the model is fit, the question is asking us to look at its outcome, interpret the model, and evaluate its accuracy. So to look at the model, we need to look at its parameters. This linear regression has two parameters. The intercept was going to be 14,508, and the coefficient, which is a coefficient of only one variable because we only have one variable, which is the Km. That intercept means that the average price of a car is 14,508, and we can double check by looking at the data and calculate the mean here. The intercept is basically the average price of the car when the coefficient is 0. Well, the coefficient is not 0 anywhere in the data because those cars are not brand new. But that says, extrapolating from the data we have, the average price of a brand new, meaning KM is 0, Toyota Corolla is 14,000 euro, 508 euros. The coefficient is basically the degree to which this car changes when Km changes by 1 unit. So that basically is saying that each increase in 1 kilometer is decreasing the price of the car by 5 euro cents. To evaluate its accuracy. So what we're going to do, we're going to use the function predict to make a prediction of the Y variable, which is the price. And then we're going to compare the Y with the predicted Y using a function called R2score. The R2score function, as we will explain in the next lecture, is basically giving us a number between 0 and 1, saying to what degree we managed to predict all of the variation in the variable Y. And this outcome says basically we managed to predict 32% of the variation in the variable Y. While it's not great, it's a good start. So only knowing the kilometers enables us to predict the outcome, which is price, predict 32% of the variation in the price. Another way to examine the model is to visualize it. And since this is a linear model with one variable, we can visualize it on a plot where the kilometer is on the x-axis and the outcome price is on the y-axis. Start by first assigning the outcome to the data frame again, because I want to plot this on the chart. And first we're going to create a scatter plot, just showing the scattering data points we have when kilometers is on the x-axis and the price is on the y-axis. So generally speaking, you can see that the more the car is driven, the less the price is. And what we actually done is to estimate a linear relationship between kilometer and price. So let's draw this relationship again here on the plot. I'm going to create another plot here, another chart that plots this as a line, and you can see that we have one line. Now it's very useful to plot these on top of each other to basically show that the regression line on top of the data, that the original data. So as you can see here, the regression line is fitting the data to a good extent, But the variation, the reduced accuracy, is the result of these data points which are further away from the line. In the next exercise, we will see how we can improve our regression model by including more variables and getting the R-score to a more higher value, almost 80%.